Alan Turing famously asked the question, can machines think? Now 70 years later, we're asking the question, can machines do material science? So we're trying to achieve this using data on structures and properties of materials with statistical deep learning models coupled with automation. So we can make predictions on new materials with particular properties and test them in the lab for the first time. Imagine running a model where the input is a list of properties that you would like. So perhaps a material that's optically transparent, that's superconducting, and that has a particular hardness. We could run a simulation that will then give us a list of candidate materials and also recipes on how to make them. So this is something that's starting to become a reality thanks to incorporation of AI techniques in material science. We are now combining machine learning models with robotics for systems that can test their own predictions. So imagine I make a prediction of a new 4-component crystal. A robotic system can synthesize it, measure the properties, and if it doesn't work, go back to the start and try again. So this is a very different way of doing material science. Not only is research becoming faster, but we can also start to tackle more challenging questions. So what happens when we mix 12 particular elements together? What structures form under extreme temperatures and pressures? So these are things that we can start to tackle using artificial intelligence. There is a major transformation happening, combining data of materials, coding, and statistics. And this is what makes AI for materials such an exciting area, and I think it's one that's going to continue to grow in the future.